Hello, it's Bud. James wants to build a wedge, and he's asked for our help. More than one of us have put in our 2 cents worth. I'm just making a video lesson that might help James and others through part of the thinking process. Let's look at what James is trying to do. He's got a wedge that is 1.5 inches at the top and 1 inch at the bottom, which is called the driver end. He has a bevel on the driver end that is at 58 degrees or by what the specs show 13/16, which would be a 0.8125. The top also has a bevel, and it is 5/16, which would be a 0.3125. There's also a 3-degree bevel on the sides. I'm not going to do that, but I will talk about it as we go through it. Okay, so let's go to the project, and let's talk about what we've got. The board settings, I've got a 6-inch width and 12-inch width from top to bottom, and 6 inches from left to right. And he told us on the second post that this wedge needs to be a 1/2 inch thick. Okay, so come over here and unhide this. We can see the whole board. Now what I did, I made the basic wedge pattern and posted it, and I've just taken that a step further. I had not gone that far yet. What I have done is taken the wedge and centered it left to right and locked it to the bottom of the board at 2 inches. Okay, then what I did was I used a rectangle, and the width of the rectangle is wider than the wedge at this point. I didn't see any point to try to make it true. We're not trying to save the outside of the board, we're trying to save the wedge itself. So my rectangle is 1 3/10 inches wide, and it is 0.8125 from top to bottom, and it is locked to that same 2-inch mark, so it is at the true bottom of the wedge. If I do an isometric view, you can see there's the taper. Okay, then I did the top rectangle, and again it is wider than the top of the wedge, which was 1.5 inches, and from top to bottom it was supposed to be 5/16, which is a 0.3125. In both cases now, the depth of these rectangles is at a 1/2 inch, which gives me the whole board, and the height is as high as I can make it, a 999. So if I look at the other one, we see the same thing. The depth is a 1/2 inch, and the height is 999. By doing that, then, we see both tapers, top and bottom. The only thing that I fear is missing is this 3-degree indication here. If that is necessary on the sides to have a taper, then it doesn't show up on this drawing. So I don't know which way the taper goes, but it would be the same principle as what we used on the taper here and the taper here, and there would be another wedge inside this wedge, in theory, but what I really want would be just a very thin rectangle, the length of that, if he's going for 3 degrees, and I would have to calculate how much I need to trim off in order to get that 3 degrees, and then set the depth at 5, ½ inch, and with a 999 height. That's the only thing that's missing, but I can't tell which way it goes, so rather than do it, I just left it this way. And that, James, should help you understand the process, and I hope it helps you build your wedge. Talk to you later.